I'm now going to work the problems for you from the rate of change mastery card 1 that you did for practice. Hopefully you've already worked them and now you're just using this to check. I am going to be going through this fairly quickly, so please feel free. This is really just a review. So make sure that if you have any questions, you ask me in class, or if you need to rewind the video and watch parts of it again, that is no problem at all. I'm going to start with number 1. Number 1 asks us to find between the table and the graph, which one has a higher rate of change. And I specifically said, do not just say one or the other. Make sure you give each rate of change. I'm going to start here with the graph just because I find it a little bit easier. So I picked 2 points on my graph that kind of hit in a corner. I picked one right there at the 4 and right there at the 2. And then I drew a little imaginary triangle. Whoops, didn't do that very straight. To see how far I had to come down and how far I had to go over. Remember, that's my rise over my run. In other words, we're calling it our change in y over our change in x to find our rate of change. It's also called rise over run. And if I'm counting here, I have to go down 1, 2, 3, 4 units down. Then I had to go over 2. So that means that it's going to be 4 over 2, not 2 over 4. Remember that that is not the easiest thing to remember, because when we've been graphing, we have lots and lots of practice with graphing the x-coordinate first and then the y-coordinate second. Well, now when we're doing rate of change, we're changing things around on you. The y actually goes on the top and the x goes on the bottom, which can make it a little bit confusing. So this 4 over 2, hopefully we realize, simplifies to a 4 divided by 2, which is a 2. And this line slants downwards, which means that it's not just going to be a 2, but the rate of change is going to be a negative 2. So right here, for the rate of change, I'd put a negative 2. Now I need to take a look at the table. Now a bunch of you guys in class earlier were looking from here to here and seeing that, as you should have, that's a good observation, that your y value, remember your output is your y, your input is your x. You guys were seeing that it was 2 less every time. So a bunch of people were saying the rate of change was negative 2 and saying they had the same rate of change. Okay, remember, that is not how we do the rate of change. What you were just noticing is what's called the function rule, which is y is equal to x minus 2. You noticed that you take your x value, subtract 2, it gives you your y value. Now that's your function rule. That is not your rate of change. Rate of change, just like I found over here on my graph, it's just in a different form, is your change in your y's over the top of your change in your x. So I need to look at how my y's are changing first. So 2 to 8 goes up by 6. And from a 4 up to a 10 goes up by 6. So my change in y is 6 over my change in x, which is 6. 6 over 6 simplifies to a 1. So my rate of change for the table is a 1. Just to double check and make sure that I didn't do it incorrectly. Let's take a look at the change between these 2 points instead. So to go from an 8 to a 1, I have to go down 7. To go from a 10 to a 3, I need to go down 7. So a negative 7 over a negative 7. Remember, our change in y over our change in x still simplifies to a positive 1. So either way that we do it, our rate of change is still a positive 1. And in this case, a positive 1 rate of change is bigger than a negative 2 rate of change. So that means that the table was the higher rate of change. Number 2, this is just another rate of change. It's just asking us for the next couple of problems. It's just asking us to find the rate of change based on the various formats. So I'm going to look at my change in y's. So if I'm going, a bunch of people said it was 0 because they were adding the negative 2 and the 2 together. That's not what we need to do. Let's say I've got a number line here and I'm at a negative 2. So go negative 1, 0, 1, and 2. So I'm traveling all the way from a negative 2 up to a positive 2. So 1, 2, 3, 4 units up. So that means that it's going to be a change of 4. From 0 up to 2, that's going to be a change in 2. My change in y over my change in my x is a 4 over 2, which simplifies to a 2. Just to make sure and just to prove a point, I'm going to find that same rate of change, but I'm going to use the other set of points that are given to me in the graph. I'm sorry, this isn't the graph, this is the table. If I use another set of points that are given to me in the table. So from 2 to 4, that goes up by 2. From 2 to 3, that goes up by 1. 2 over 1 still simplifies to a 2. So either way, my rate of change is a 2. Number 3, Sam has $75 in her piggy bank. You guys, each week she saves $12 and adds that to her bank. What is the rate of change? Okay, so those of you that have done your vocab project or been listening in class, that $75, the amount that she starts with, is called the initial amount. So that's what she starts with. Then every week she saves another $12. Well, how much does her bank account increase every week? It increases by $12. So therefore, $12 is the rate of change. If I wanted to get technical, I would say $12 per 1 week, or I could say 12 per week and leave out the 1, whatever. But either way, the rate of change is still a 12 because every 1 week her balance goes up $12. Number 3, in a linear function that is in slope-intercept form, like this one is, the rate of change is really easy to see. But I'm going to prove to you why it works. Okay, I'm going to pretend for just a second. Let's say instead of an x, we put a 1. So I'm going to make that an easier color to see there. Here we go. So 3 times 1, so if x were 1, 3 times 1 is 3. 3 plus 6 means that y would be 9. If an x were a 2, 3 times 2 is 6. 6 plus 6 would be 12. Oops. If x were a 3, 3 times 3 is 9, plus 6 is 15. So now let's take a look at that rate of change. So from 1 to 2, it goes up by 1, goes up by 1. Here, it goes up by 3 every time. Remember that your rate of change is your change in your y values over your change in your x values. 3 over 1 simplifies to a 3. So I've just proven why, when it's in this format, your rate of change is always that number right in front of the x. So you really didn't need to do all this work that I just did. I just reminded you and kind of proved to you why that 3 is the rate of change. That 3 in front of the x, because every single time x increases by 1, your y increases by 3. This one asks which one has the greater rate of change, and it also said make sure that you state the rates of change. Don't just say which one is the bigger one. I know on this screen here it's a little bit hard to see exactly where the graph hits certain points, but on your paper I think it's a lot easier. First of all, on both of them, they both hit right there at the corner at 0, 0. So that helps. Remember, you can pick any points that you want, but it's definitely easier if you pick some points that kind of hit a corner. Makes it easier to count. So then I notice that right here, this point over 1 and up 1.5 hits right there at the corner. And then there's another one on this graph that hits right there in the corner. There are several that I could have chosen. Those are just the ones that I chose to use. And actually, if you notice on your handout, they're kind of labeled. You can't see it on here. There's an F and a D right there just to kind of help you maybe to point out that those are a little bit easier to see. So again, I just picked 2 points on each line that were kind of hitting in a corner right there, so they were easy to count. I'm going to draw my imaginary triangle for the first one. Now, this is one of those cases where they kind of mess with you a little bit as far as the scale. Because if you're just counting how many places you had to move up, you're going to be wrong. Because you might count 1, 2, 3, 4, 5, and 6 when you really just went up 3. Because you notice that each little tick mark actually counts as a half. So for this one, I went up 3, and I didn't go over 1, 2. I actually just went over 1. So the rate of change for B is 3 over 1, which simplifies to a 3. For graph A, I'm going to draw my imaginary triangle going this way. So I had to go over 1, just like the other one, but I had to go up to 1.5. So the rate of change for A is 1.5 over 1, which simplifies to just a 1.5. So which one has the greater rate of change? That would be B, because its rate of change is a 3. The other one, graph A, is just a 1.5. Remember, change in Y over your change in X, your rise over your run. Number 6, it gives us a function that is graphed, and it asks us which of these equations has the same rate of change. So first of all, I got to figure out the rate of change for this one. Now, I can use this point that they give me, but man, I don't like it when they don't hit a corner like that because it's a lot harder to count. I personally would prefer to use this one right here because that 0 sure does make it a lot easier to count. I'm going to draw my little imaginary triangle. This point hits in a corner, so that's going to be easy for me. So as I move from left to right, I notice I travel from 0 all the way over to 5. So my run, that is my change in Y, is a 5. When I go up, I've got to be careful about my scale because I'm actually going from 0 all the way up to 40. So I'm not going up 4, I'm actually going up 40. That's one of their favorite things to do in math land on these tests, is sometimes kind of catch you not paying attention. And the scale here is a lot different. This is not a 4, this is a 40. So I need to do my change in Y. So that would be my 40 over my change in X, which is a 5. 40 over 5 simplifies to an 8 for a rate of change. The only equation that has a rate of change of 8 would be C. Remember, when it's in slope-intercept form like this, the number that is in front of the X is always your rate of change. Number 7, again, what is the rate of change? So I need my change in Y over my change in X. I'm going to go up 17. This one goes up by 2. So that means it's going to be 17 over 2, which simplifies. You can actually leave it as a 17 over 2 if you leave it as a fraction. Or if you took it a step farther and divided, I would count it either way. 17 divided by 2 is 8.5. So I would actually accept either answer. I would take 17 over 2 as a fraction because that's in simplest form, or I would take an 8.5. Either one is just fine. Number 8, as we've discussed in a few previous examples, the rate of change is always this number in front of the X, as long as it's in a Y equals format. So Y equals something X, that is going to be your rate of change. So, easy enough. Just take a look at it. My rate of change is just a negative 2/3. I'll prove it to you just to make sure that you get it. So, if X were 0, 2/3 times 0, of course, would be 0. If X were 1, negative 2/3 times 1 would be a negative 2/3. If X were 2, Y would be a negative 4/3. So see how every single time it's going down by 2/3 because now it's 2/3 and then 4/3, etc. So that negative 2/3 is your rate of change.